5A is about graphing functions, and all of this stuff is review. You have done all of it before, and so in the past, I have not given any notes, and I've just said, hey, here's the assignment, do it. But especially for like people that are gone, I thought they might feel better if they had some notes or just like a review. So we are going to be graphing functions, like I said, and you've been graphing these functions for years. This is directly out of your textbook. Pretty much everything straight out of the textbook, so I don't know that you need to write anything down because you can just turn to the section and see it. But these are some of the things that we've graphed. We've graphed linear functions before. We do that a lot in Algebra 1. You do it in geometry. Quadratic functions with like the x squared we've done before. And then cubic. Have you graphed cubics last year? I know we haven't this year, but I think that most of you guys should have graphed cubics in trig whenever you took trig. Exponential functions we graphed this year, so that's like a to the x. Logarithmic functions we have already graphed last chapter. Reciprocal functions we graphed in chapter 2 with like that x in the denominator, sometimes called rational. We're going to take a look, and I'm going to show you like the general picture for all of these, just in case you don't have the image of what the general shape is in your mind. We'll look at that. But what this whole section is that by the end of this chapter, you should be able to look at a function and kind of understand what it's going to happen. Like, if this a is negative, you should understand that it's going to flip it upside down. If this a is like a big number, it's going to get narrower. It's going to be a stretch. If it's a smaller number, it's going to get wider. If we are adding and subtracting, like what that does, that moves it up and down or left and right. So not today, but when we get into it next week, you're going to kind of explore these different types of transformations and then be able to recognize them. For when you look at an equation, you should be able to tell, okay, this is what's going to happen. It's going to move left and get flipped upside down or whatever. So we're going to do it slowly. We're not going to like do everything at once, but that's the main point of this section. And not all of you will use this for your IA, but I know Ms. Ewan says that a lot of IAs do use this chapter. Like she says, it's one of the most important chapters going into thinking about your IA stuff for next year. So really try to gain the understanding as we move forward through next week. So here are those basic curves, same curves we were just talking about. We know what linear looks like a line. Quadratic, we've seen a ton of those, looks like a U, right? The parabola. That cubic, I know like we haven't graphed any this year, but you guys recognize that shape, kind of that weird curve sort of thing. So you do have one on today's assignment, then you're going to use technology to help you graph it, but so we've got that kind of weird curve there. Exponential we talked about. Notice how it's not negative or anything and it's kind of going straight up. The logarithmic is that reflection of that one we were just talking about. So our logarithmic ones. The reciprocal or rational functions, remember that's when we divide by x, and so we have like a curve in two quadrants. You know, you might be the other two depending on how it's reflected, but we graphed those. We had a whole section on those in chapter 2. This is just a bonus. Does anyone know what type this is? It was not up there before. I'm just curious. This one is, apparently I gotta plug that in. Where that works. This one is f of x of the square root of x. So I know we've seen it before, so I just kind of threw it on as another reminder of what that graph kind of looks like. So next we're going to talk about those key features. So key features, again, this is straight out of your textbook. We know about the axes intersect, so that's where the graph cuts the x and y axis. We've looked at this prior to today, this year. We know we can find those intercepts graphically by actually like graphing it, looking at the graph and looking for where it crosses the x and the y. We also know that we can substitute in 0 to find these intercepts. If I want to find out where it crosses the x, I plug in 0 for y. If I want to figure out where it crosses the y, I plug in 0 for x. So we've done these both graphically and algebraically before. Turning points we have found before, it's like a local minimum or a local maximum. So when you think about your parabolas, we've talked about minimums and maximums, but you could also have turning points on like that cubic function where there's not like a full-on maximum, but in that little curve, you can find the local maximum in that little area, or the local minimum is where that curves. And again, it's got that name turning point. So it's when we're going one direction, we're turning and going the other direction. So that word turning point really helps you envision what that looks like. We've also talked about the values for x, which the function does not exist. In chapter 2, we talked a lot about how we could find both graphically and algebraically where a function was undefined. Like we can't divide by 0, we can't square root a negative. So we've done that before. And related to that, the presence of asymptotes. So we know sometimes when we have that undefined piece, there's like a line in our graph that it comes really close to, like those reciprocal or rational functions, like they get really close to, but they don't actually cross. So all of those things we've already, we've done before this year. Something to note just with the language, and primarily we'll be doing sketching, but if you're asked to sketch a function, it should show the graph's general shape and its key features. So you don't have to necessarily have it drawn to scale, you don't need to have it look perfect, but you sketch the shape and then you put in the key features. So like if it is a cubic, you want to sketch that cubic and then maybe put in the minimum and maximum, like the local minimum and maximum, put in those turning points. If you know where it crosses the x-axis or the y-axis, you would put those in. So it doesn't have to be a perfect looking graph for a sketch, but do put in those key features. Label them on your picture. On the rare occasion you're asked to draw a function, that would be when you want to pull out the graph paper. And it's not going to happen very often, but just for your information, if you're asked to draw a function, it should be done to scale. So that is when you're going to want to have that graph paper there and have it look pretty much exactly the way it looks. There's one more thing I thought to add to this. When we want to solve for something like this, like you're going to see this on today's assignment, so f of x equals g of x, like two different functions, what you want to do, and we're using technology today. In the past, we've done this in chapter 1, where we set the equations equal and we solve for x, we plug it back in and all that, right? Today they're going to be a little bit more challenging, but you do not have to do them algebraically. I want you to put them into whatever technology you're using, and you just look for where those graphs cross. For example, let's say I have a cubic that looks like this, and I don't know, a rational function that looks like this. I'm not doing a great job. But then you would plug them in and you would look for, okay, my smartboard got really weirdly aligned, but like those three spots are where it touches. Again, my green got kind of crazy. Do you guys get what I'm saying though? So when you see that, you don't have to do it algebraically. You just put both of them in decimals or both of them in your graphing calculator, and you look for the spots where they cross. So I just didn't want you to like feel weird about that, because we've done it before algebraically, but we didn't really do it graphically at that time. Are there any questions or apprehensions about this graphing stuff that's coming up right now? Okay. So that is it. There's just a couple that you need to sketch for your assignment. Graphing calculators are in the black box. I do have the nicer computers ready for us for next week. So if you want, I can open that up so you can use those for your graphing stuff. I really think that even though this assignment's not due until Tuesday, December 1st, right, 2 days, you can get it all done now and not have to worry about math over the holiday weekend. I believe that you all can do that.